Well, good morning. I'm excited to see you here. These are the students who I should remember at the end of the semester, right? The ones who came to class before spring break. The really, truly committed students are here in the classroom today. And for the rest of the students, maybe they're watching the video, so who knows? All right, let's begin by looking at a few announcements here. The homework assignment that you're working on right now, homework 10, benefit cost analysis, that is due when you come back from spring break on Sunday, April 10th. And also the big event on Sunday is that we're having the midterm exam in this room during the normal class time. And so I've written the exam. There's going to be one Excel question, the other two problem-solving questions you'll do on paper, and then there's also some short answer questions related to concepts. Do you have a question? Delay the exam? Unfortunately not, yeah. Why? It's because we have a long list of things that we need to do this semester and there's no slack time. I think the course is relatively straightforward if we keep on schedule, but if we start trying to pack too much information in any one class, then it would become really confusing. So it's just, that's how the schedule worked out. I don't like it any more than you. Unfortunately, we've got to do these exams. Yeah, good question. So the coverage material is since midterm 1 up through and including today's class. So if you go over the course schedule document that I handed out at the beginning of the semester, and it's also posted on iLearn, then that will show you the topic from each day's class. All right, so I will be providing, as I mentioned last time when I made the announcement about the exam, I'll be providing an equation sheet. And there actually aren't very many formulas, but what you need to know is procedures and understand the material. Is there a mouse running around back there? Seems like a lot of commotion. No? Okay. All right. So any other questions? Today we're talking about something new. It's another way of analyzing how effective organizations are. So far we've been doing benefit cost analysis, and in last class period, incremental benefit cost analysis, but today is cost effectiveness analysis. So it's kind of an interesting procedure, and let's get into it. Before we do the calculation stuff, though, we need to talk just briefly about ethics. And the reason I bring it up is that in benefit cost analysis, remember that a lot of what we're considering are subjective activities, and we're trying to put a dollar value on things. And so we're trying to say, for instance, how much it is worth, how much money it is worth if there's some extra noise in an area. And sometimes it would be tempting to play around with the numbers if you want to encourage a project or if you want to kill a project. So let's say that your company is being hired by the airport authority to do a study of the benefits and the costs of the airport expansion. Now, of course, the airport authority wants their project to go forward, and they're the ones paying your company, and so maybe there would be a temptation to minimize the costs, to minimize the disbenefits, and to over-exaggerate the benefits. And so that can be a really problem. So what you need to keep in mind is that engineers aren't only doing design. Sometimes we work on projects that tie into public policy and planning, and it has a lot of implications that affect society. And so as engineers are working, they always need to be impartial, meaning that they have to make decisions and recommendations just based on facts and not based on if it will benefit friends of theirs or if it will benefit their own company. They just need to actually stick to the truth. We need to be realistic in making assumptions. And sometimes we can make the costs look smaller than they actually are if we exaggerate the lifespan of a project. And so you need to be realistic in how long things will last, or be realistic in your assumptions about the maintenance and operation costs over time. And being thorough means that we have to consider a whole range of circumstances. And so for instance, there was a big fire in Ajman. I'm sure everybody heard about, another high-rise fire. But it would be interesting to go through the design of that structure and see if the designers were thorough to consider the possibility of the aluminum cladding catching on fire in that high-rise. And if that was recognized as a risk, or if that risk wasn't caught because they weren't considering a wide range of possibilities. No one usually thinks of the outside of a building catching on fire. I mean, what I would have thought of as the higher risk is the contents of the building catching on fire, but recently it seems like it's the outside that is what's transmitting the fire along the building. So the broad point is that economic analysis, there can be a temptation to misuse it because you're having to assign monetary value to subjective things, and so it's an art as much as a science in some cases. But we shouldn't use that flexibility in an unethical way. Mm-hmm. Well, you need to try and brainstorm everything that could possibly happen. Excuse me? Right. Well, the probability of something happening may be small, but then the cost of it could be high. So let's take, for instance, the construction of a dam. When a dam is built, because if a dam fails, it could send a lot of water to people who are living downstream. It could flood an entire city. And so ordinarily, when a dam is constructed, they consider the worst case scenario that could happen over like a 5,000-year period. Even though the dam itself may only last for 100 years or maybe 200 years at the most, they consider such a wide range of possibilities. They're thinking about 3 storms coming together over the dam area at one time. Even though that's very unlikely, they weigh the risk of something along with the consequences of it happens. And so in the case of a dam, they wildly overconstruct based on what could go wrong. Now, it may not always be necessary to do that. For instance, if you're just sizing the drainage system next to a road, you know, it's important for the roadways to be clear of water, but if water accumulates in the roadway, it doesn't have the same risk as if a dam fails. And so you don't have to consider the 5,000-year storm for designing the drainage on a road. More typically, what they try to do is make sure that the roadway is clear for a 10-year storm, meaning a storm that comes through once every 10 years on average. So that gives you an idea of what I mean by the wide range of circumstances is, you know, do your best to try and figure out what can go wrong in a project, and if possible, put a dollar value on all those possible disbenefits, all the possible costs, so that your B2C analysis is realistic. All right, so is it ethical to accept publicly funded projects where the benefits are excluded to certain people? Meaning, would it be ethical to build a park only in the rich neighborhood of a city, and then in the poor neighborhood of the city to not build parks for people there, even though it's paid for with government money? You know, obviously that wouldn't be ethical. What the question illustrates is sometimes the benefits don't go to everyone. Sometimes the benefits of a project go into a few people's hands, but then the costs go into a large number of hands. So here's another instance. Is it ethical to accept expensive long-term projects that will add to the debts for future generations? This is something that a lot of people in the United States are worried about, that, you know, our government has huge debts. The American government has huge debts, and they just keep borrowing more and more money. And so people are starting to think, well, we've borrowed so much money as a country that now it's like the children have that debt, and so we're spending money we don't have. And is it ethical to force people who aren't even born yet to pay for things that we're enjoying now? Maybe, maybe not. Is it ethical to allow projects where disbenefits have a disproportional effect on poor or minorities? So just like the benefits can go into a few number of people's hands, sometimes the disbenefits are disproportionately put onto the poor people. And an example that the book raises is freeway construction in Southern California. There are so many roads and so much congestion in Southern California that it was common, as those roads were being built, to put the highways through poor neighborhoods, just because it was found that people who are poor are so busy working that usually they don't have time to complain to the politicians or to attend public meetings to raise their concerns. And so it's sort of like picking on the little guy is the easiest thing to do for the project planners. And so it's not ethical to keep the benefits for a small number of people, and it's not ethical to make sure that the disadvantages go to the people who are the weakest. Also, is it ethical to monetize elements of a project costs, benefits without additional consideration? So, you know, money isn't everything, and that's a point that I made in class on Sunday, that, you know, it's not all about how much money you can have. Also, you know, if you're polluting the environment, if a company is taking hazardous waste and just dumping it into a river someplace, then, you know, that's an additional consideration that you have to think about, even though the river maybe is a convenient place to dump toxic waste, then you shouldn't just be trying to maximize your revenue. And so environmental considerations, safety considerations is another one. You know, even though you can make a high profit by exposing workers to really dangerous conditions in mines or in factories or at construction sites, it's still not ethical because you're putting their welfare and their well-being at risk. And so it's not, in this class we talk a lot about maximizing profit and having the highest rates of return, but there are other considerations like you know, human dignity and self-respect and environment and safety that we have to also consider. One last question. Is it ethical to disregard certain options because it is difficult to estimate or quantify them? So we are engineers and we love numbers. And sometimes we love numbers too much. We love numbers so much that we'll have a bias in favor of plans that are easy to quantify, and we'll be less interested in plans that are difficult to quantify. And so if there are benefits or if there are costs that we have a hard time putting a firm number on, sometimes we have a bias against those types of projects. And so it's not ethical to disregard things just because they're difficult to measure. All right, so that was just a quick taste of ethical considerations. There's a lot more in the book about that, and I'd encourage you to have a look. The bulk of what we're going to be spending our time on today is known as cost-effectiveness analysis. And the bottom line with this is that it's a way of measuring how good organizations are at doing a service rather than building a product. In a lot of countries, intangibles or services are a big part of the overall economy. So take, for instance, someone who's an accountant. They're not necessarily building something that is going to be sold in a store, but an accountant provides services. And the same is true for people who are working at the airport and the immigration people. You know, some of the immigration people, you try and figure out which line to stand in. You can see one of the line is moving quickly, one of the lines is moving slowly, so you shift lines maybe. You know, some people are fast and some people are slow. And what cost effectiveness analysis allows you to do is put together a numerical way of identifying which offices or which organizations are most efficient at doing intangibles like service sectors. So this method is applied a lot in sectors such as healthcare, accounting, the police, safety training. And so we want to get the most return and invest in organizations that are being efficient. Now, why do we use this new cost-effective analysis instead of B to C ratios? And that is because the benefits are sometimes hard to estimate. For instance, the police. We couldn't do an easy B to C analysis because it's tough to say what is the economic benefit of having a policeman on the street, you know, checking traffic, preventing crime. And so, you know, their being on the job is going to prevent a negative thing from happening. And so since we don't know what would have happened if they weren't there, then it's difficult to be exact about what the benefit is. And the same thing is true of traffic cameras. You know, the traffic cameras help to slow people down on the roads. And actually there was an article in the paper just the other day that was saying, you know how the limit now is 120, but really you can drive 140? The article in the paper was saying that what they're considering doing is making the limit 130, and then there's no buffer. It's 130, and then the tickets begin at 131. So it'll be interesting to see if they end up doing that. Because the whole point of the traffic cameras is to try and prevent people from speeding. And the benefit is to save human lives. And so there's just certain things that it can be difficult to put a monetary estimate on, and so this cost effectiveness analysis is just another way of ranking alternatives to try and find out which one is the most efficient. So the types of things that the traffic cameras does, averting accidents, deaths prevented, both of these things are hypotheticals that don't happen, instead of they would have happened if the traffic camera wasn't there. And so trying to predict the monetary value of something that didn't happen can be very challenging. So here's the formula that we're going to be using today for our cost effectiveness analysis. It's actually very simple. What we're going to be doing is putting the costs of something in the numerator and then some measure of how effective the organization is in the denominator. So take, for instance, someone who's working at the immigration desk at an airport. The way that we would apply this is we would take all of the people who are on duty at one time, and we would look at the cost, so in other words, their salary during the time that they worked, and then what would be a measure of their effectiveness? How could you measure how effective they were during their shift? Okay, speed, and so how would you measure the speed? How many people passed through? Right. So one way of doing it would be salary divided by the number of people who were considered. But of course, there's other ways to do it as well, because we don't just want them to be saying yes to everyone who comes in. So another way of measuring the effectiveness might be, how many people did they spot that weren't supposed to get into the country? And so there's a lot of different ways that we can measure effectiveness, and it all depends on what sort of a business we're in. So in the case of the police, it might be the costs of a certain police station divided by the number of criminals who are arrested. Or it could be, the measure of effectiveness could be the reduction in crime over time. Yes? Usually what we'll do is we'll use one variable, but we can create a cost effectiveness ratio based on lots of different ways. And so you could do one ratio that's based on the number of crimes prevented, like a reduction in the crime rate. You could do another one based on the number of thefts that had been solved. And so you could compare it on a lot of different metrics. Good question. All right, so here's an example of how we apply the method. Let's say, for instance, that there's 4 different offices where they're processing passport applications. And so Office A, just based on how many people work there and the value of the real estate and the machines that they have, the total costs of Office A, including all of the things that go into the cost, are $875 per hour. And you can see that, for instance, Office C is more expensive. Maybe it's a bigger office with more people. Maybe it has, it's in the more expensive part of town, so the rent is higher. Some of them are cheaper. Now, in column 3, we're seeing the number of applications per month that they're processing. And so that's going to be our measure of effectiveness. So that if we calculate C to E, this is basically how many dollars it takes to process each application. And so there's a reason why, for example, maybe Office B has a lower number, 8,900, compared to Office A. Maybe they have a lower number of applications processed because there's fewer people there working, and that's why the costs are lower. But this is a way of normalizing it, leveling the playing field. And so if you're the manager of the region that these 3 offices are in, what you can do now is compare them directly. You can say, it looks like Office D is the most expensive. They're not being efficient in Office D, whether it's too many people or too expensive rent that they're paying, but it's costing 10.8 cents per application processed, whereas Office B is the most efficient. It's only costing 5.1 cents for each application that's being processed there. Okay, now I'm making a switch between these 2 slides. Look, let me go back to the previous one. We've got A, B, C, D, so it's just in order of the letter. How have I reorganized this now? B, A, C, D. It's organized in terms of the most efficient on top, so that's, we could say, is the best office, and we have the worst office on the bottom. So I've just reorganized it in terms of most efficient at the top, least efficient at the bottom, and added a new column. Column 5 here is called cumulative cost. And what I'm doing is I'm rationing capital, because we don't have an unlimited budget, so we want to spend our money first on the office that is the most efficient. Like if we have to make cutbacks and we're closing one of the offices, then what we would do is we'd find out what's the cumulative cost for opening office B is just $4.50 per hour. But now for the column, column 5, the cumulative cost column on office A, I'm combining having office A open and office B. And so this $13.25, the cumulative cost, is just saying, what if we have both office A and office B in operation? And so you can see that now office C is the previous value, $13.25, plus an additional $1,100, and so on. So the reason this can be useful is if I had an overall budget I can only spend $2,500 per hour, then it tells me I should open office B, A, and C. But then if I only have $2,500 an hour as my budget, then I shouldn't go with office D, because I want to maximize the number of applications that are processed for every dollar that I'm spending. So if it's $1,600 per hour, then that tells me just go with offices A and B, because that is the limit that I can spend. Sometimes a partial allocation is available. So for instance, if we had $1,600, then we would fully fund B and A, and then we maybe are able to partially fund office C. But that's not always possible to have a partial funding. Well, that's an interesting question, yeah. So this is data that was taken when all 4 of the offices were open. So the point he's raising is, if we close office C and D, there's still lots of applications that need to be processed, and so can they be efficient at office B and A? And so what we'd need more information. We'd need to know what went into these costs. Is it just because they have, maybe the building has cheaper air conditioning costs? Or maybe it's that the rent is lower. So maybe if we move more people to office B, they can still have the lower cost per application. So this C to E ratio, maybe they can have the same C to E ratio, and that's really what we're trying to optimize, is how much money we spend for each application that's processed. So maybe the overall cost would go up, but then the applications per month would also increase if we shift people. That's a good question. So this idea of a budget is called capital rationing. And what we're going to do in today's in-class exercise is we're going to look at the case of trying to prevent guerrilla poachers. So let me hand this out. We have some data for 5 different NGOs. And what we're trying to do is look at how much they spent versus how many poachers they've arrested. And so we've got cost and we've got a measure of effectiveness, and what you're going to do is set this up in Excel similar to what I just showed you on the screen. There's going to be 5 columns. Let me unlock the computers for you if they're not already. Okay, now this is a little tricky because the costs you're given are cost per person. You have personnel and cost per person, and so you're going to need to find out the total program cost for each of the NGOs, so that the total program cost is going to be your measure of C. And then this column, poachers arrested per year, this is the effectiveness. So the final column you're calculating is a C to E ratio. And don't just use the cost per person, because this is how much they're spending for each of their personnel. We need to know the total organization's expense. So multiplying personnel and cost per person together.